5 times, life on Earth was nearly erased. But what if scientists missed one? A hidden extinction older than the dinosaurs, buried so deep in time, its victims left barely a trace. If it's real, it changes everything we know about how life survives and how it ends. What if Earth had 6 mass extinctions, not 5, and the first one is still hiding beneath our feet? Far below your feet, deeper than any cave or tunnel, the Earth holds secrets written in rock. These rocks aren't just hard and grey, they are stories, pressed down through time, one on top of another. Each layer is like a page in a giant book, and this book is older than anything people have ever made. If you could read every page, you'd see the whole history of life on Earth. You'd see strange jelly-like creatures swimming through warm oceans. You'd see giant trees taller than buildings, and dragonflies the size of hawks. You'd see monsters with teeth like swords walking through thick, steamy jungles. You'd even see tiny furry things hiding in the shadows, waiting for their chance to rise. But here's the scary part. Sometimes the pages go blank, whole chapters vanish, and when they come back, the world is different. The creatures are gone. The air has changed. The ocean is quiet. This is the story of mass extinctions. Mass extinction doesn't just mean a few animals die, it means nearly everything dies. In a mass extinction, over half of all living things, sometimes even more, are wiped out in a short amount of time. Imagine walking into a forest, and every bird, every squirrel, every bug is gone. No chirps, no buzz, just silence. Then picture the oceans, once filled with swimming creatures, now still and empty. These are the Earth's biggest tragedies. Scientists believe 5 of these great wipeouts have happened so far. They are like giant breaks in the story of life, and each time, Earth had to start again. The first mass extinction came when most life lived in the sea. The second brought down coral kingdoms and armored fish. The third was so terrible that nearly all life vanished, both on land and in the water. The fourth killed off many reptile-like creatures, but made room for the dinosaurs. The fifth brought fire from the sky and ended the reign of the dinosaurs, making way for mammals like us. These 5 are known, named, studied. We tell their stories in museums, in science books, and in classrooms. But what if we missed one? What if the count is wrong? What if there weren't 5 great extinctions, but 6? It might seem like we would know if such a thing had happened, but Earth is not like a clean, flat book. Its pages are torn, burned, crushed, and buried. Rain eats at the surface. Volcanoes cover the past in lava, mountains rise and fall, oceans appear, then dry up. Fossils, the bones and shells of ancient life, are rare. Most things that ever lived left no trace. They were soft, squishy, and fragile. They disappeared without a sound. So it's not easy to spot every break in the story. And some scientists believe there is one break we haven't fully understood yet. Before the first official extinction, something strange happened. Life had just begun to boom. In a time called the Cambrian, around 500 million years ago, Earth's oceans were alive with weird creatures. Some had hard shells, some had dozens of legs, some had eyes on stalks. Then, suddenly, many were gone. No asteroid, no lava flood, just a silence in the rocks. Fossils vanish, shapes change. It's like turning the page in a book and finding the characters replaced. This strange gap isn't on the list of 5 mass extinctions, but some scientists wonder if it should be. They point to odd patterns in the fossils. Sudden disappearances, sharp drops in the number of species, a big fall in ocean oxygen levels. These signs look a lot like the other 5. Maybe the first true extinction wasn't the one we thought. Maybe something happened before the first. Why would this matter? Because it changes the way we see Earth. Right now we believe that life grew slowly, then got knocked back 5 times. But if there were 6 extinctions, then the first one came much earlier. That would mean life faced deadly tests from the very beginning. It would show that the fight to survive is older and harder than we thought. And if we missed one extinction, could we have missed others? What if the history of life is filled with silent ends that left no bones behind? What if there were tiny wipeouts, hidden under miles of rock, that shaped the world in secret? The truth is, we don't know, but new tools are helping. Scientists now scan rocks with lasers, looking for sudden changes in metals, gases, and dust. They drill deep into ice to catch bubbles of ancient air. They slice open tree rings, coral shells, and even crystals, hoping to read Earth's memories. They are searching for the smallest clues that something big happened. Because the past tells us about the future. Each extinction changed the world. After one, insects ruled the sky. After another, mammals took their first steps. Extinctions are not just ends, they are doors. When one life goes out, another begins. But every door comes with a price. And right now, many scientists believe we may be opening a new one. Today, animals are vanishing again. Forests are falling, oceans are warming, ice is melting, creatures are dying faster than ever. Some call this the sixth mass extinction. But if the real number is already 6, could we now be facing the 7th? That question gives this story a chilling edge. We may not be reading about history, we may be living it. So we must look back. We must search the rocks, the ice, and the bones. We must ask hard questions. Did we miss something? Is there a lost extinction, waiting to be counted? Is there a hidden moment when Earth shook, the seas changed, and most life quietly slipped away? This is where our journey begins. Not in the age of dinosaurs, not in the time of mammoths, but in a world much older, much stranger, and far harder to understand. A world where the first great mistake may have already happened, and we just forgot to write it down. Welcome to the mystery of the missing extinction. Let's turn the page. Long ago, before dinosaurs, before trees, before bones were common, there was only ocean. Earth had no grass, no flowers, no birds in the sky. The land was mostly empty, but the seas were alive. Strange creatures moved through warm, shallow waters. Some looked like pillows with legs. Some looked like tiny submarines with eyes on stalks. This was the Ordovician period, around 485 million years ago. The ocean was a blanket of blue-green, stretching as far as the eye could see. Beneath the surface, coral reefs grew like underwater cities. There were trilobites, which looked like bug shields crawling along the bottom. There were floating jellyfish, long squishy worms, and giant nautiloids, swimming like slow rockets with shells. For millions of years, life in the sea bloomed. It grew in numbers and kinds. It built a world full of shapes, colors, and movement. But then something went wrong. First, the temperature began to drop. Slowly at first, like a quiet whisper, turning into a cold wind. The water, once warm like a summer lake, started to chill. Ice crept across the southern part of the planet. Glaciers formed, growing bigger and heavier each year. Sea levels began to fall. Shallow seas that once covered the continents disappeared. The coral cities were left out in the air, like fish bowls tipped over. Creatures that lived in the light and warmth of those seas had nowhere to go. Some tried to swim to deeper waters, others stayed and waited, but the cold kept coming. The oxygen in the water dropped. Some parts of the ocean turned into dead zones. No fish, no worms, not even bacteria could live there. The currents changed too. Food from the surface stopped sinking to the deep. Everything began to slow down. Life became quiet. Then, very suddenly, it wasn't quiet anymore. It was gone. Scientists believe this was the first mass extinction in Earth's history. It's called the Late Ordovician extinction. Nearly 85% of all species in the ocean vanished. Whole families of animals disappeared forever. It happened in 2 waves. First when the planet cooled and the seas shrank. Then, when the ice melted too fast and the seas flooded back, bringing chaos once again. It was like Earth pressed a reset button. The world before the extinction looked nothing like the one after. In rocks from that time, scientists see the change. The fossils before the extinction show rich, busy sea life. There are shelled creatures, tiny filter feeders, and sea lilies anchored to the sea floor. Then, the layers turn dark. There are fewer fossils. Some are broken or spread out. Then, new creatures appear. Simpler ones, smaller ones. The trilobites come back, but not the same kinds. The corals are different. It's like Earth forgot the old song and learned a new one. But even now, with all our science, we don't know exactly why it happened. We can see the ice, the falling sea levels, the changes in oxygen. But what started it? Was it a shift in the Earth's orbit? Was it a giant volcanic eruption that blocked the sun? Was it something else entirely? Some think that even back then, the Earth's climate was very sensitive. Just a little push, and everything changed. The seas got colder, then warmer again, and life couldn't keep up. Imagine being a trilobite during that time. One day you're crawling through a reef, finding food, feeling the currents. The next, your world is shrinking. The light is dimmer. The food is gone, the water feels heavy and strange. You crawl, but there's nowhere to go. Above, the glaciers grow bigger. The wind howls across empty land. Below, life flickers like a candle in the wind. And then darkness. What makes this extinction so strange is how it happened so early in Earth's story. Life had only just begun to grow bold. It was still young, still learning to stretch and explore. Yet already, the Earth gave it a terrible test. Could life survive a deep freeze? Could it rebuild after being torn apart? The answer, somehow, was yes. But not without scars. This extinction was different from the others. No asteroid crashed into Earth. No fire swept across the land. Instead, it was slow, cold, and quiet. The killers were time, ice, and change. And the lesson was clear. Even the seas, which seemed so full of life, could empty in a blink. The proof is locked in ancient limestone. These rocks, once the bottom of warm oceans, now lie on mountaintops. In places like Scotland, Canada, and China. Scientists chip away at cliffs to find tiny fossils. They count them. They compare them. They watch as the numbers drop and the kinds of creatures change. In these tiny bones and shells, the story of the Ordovician extinction unfolds like a sad song with missing notes. It is the first chapter of a painful pattern. Life grows, life spreads, then something happens. A freeze, a flood, a fire, and life is cut down. Then, over millions of years, it grows back. New forms appear, new rules, but always with risk. Always with the shadow of another end. And this first extinction sets the tone. It shows that Earth is not always safe, that even in the early days, the planet had sharp teeth. It reminds us that mass extinctions don't wait for dinosaurs. They don't need space rocks or giant beasts. They can come from tiny changes in the way the Earth breathes. And here is where the question begins to grow. If this is the first known extinction, if it happened 445 million years ago, what came before it? What don't we know? The fossil record is not complete. Before this time, there are fewer bones, fewer shells. The animals were soft, they didn't leave many traces. But some scientists think there was another crash before this one. A silent one. A lost one. A sixth extinction that should really be first. This idea whispers through the rocks. In gaps. In sudden changes. In missing pieces. If it's true, it means this Ordovician event isn't the beginning of the danger. It's just the first we can clearly see. The real beginning might be even farther back. Lost in the folds of time. Waiting to be uncovered. So we look again at the rocks. At the sea, at the clues. We try to listen, not just to the stories we already know, but to the ones the Earth is still trying to tell us. Stories that begin before the first frost, before the first shells, before the first extinction we've counted. Because if one was missed, what else is hiding? What else have we forgotten to name? What if the list begins, not with 5, but with 6? And what if that 6th chapter is the key to understanding why life always seems to fall, then rise again? The world after the Ordovician extinction was quiet, like a room after the music stops. Coral reefs were gone. Trilobites, though some survived, had fewer kinds and lived in fewer places. The shallow seas, once full of light and movement, were still and cold, but life came back. Slowly, the water warmed again. Oxygen returned to the deep. Plants began to creep up on land, green and low to the ground, like carpets on bare stone. Tiny bugs scurried across the surface, making the first tracks in mud that would one day turn to stone. Fish swam deeper, faster, and smarter. Their bodies changed. Some grew jaws, some developed strong fins, some began to hunt. This new world was the Devonian. It started around 419 million years ago. It's sometimes called the Age of Fishes. And for good reason. The oceans filled with strange new creatures. Some fish looked like sharks with armor. Others had bony heads like helmets. Some were flat and wide, hiding on the sea floor. Some had long tails for fast swimming. There were even fish that used their fins like little legs to push along the bottom. It was a time of speed, strength, and survival. Coral reefs returned, growing into huge, colorful forests underwater. Above, the land was still quiet, but it was changing. Small trees stretched upward. Insects flew low, just above the ferns. The air was warm and heavy. Rain fell often. Rivers cut deep into the ground, flowing to the sea. But not everything was safe. The world was changing again, and not in a good way. Deep in the oceans, something was going wrong. Oxygen started to vanish. It began in pockets, places where the water didn't move much. These places became dead zones. First, the small fish disappeared. Then the corals began to bleach and crumble. The water turned dark and thick. Soon, whole parts of the ocean were lifeless. This wasn't like the cold crash of the Ordovician. It was slower, stranger, a long fall, not a quick drop, but the result was the same. Life started to vanish. This was the Devonian extinction. It didn't happen all at once. It came in waves. Scientists think there were at least 4 or 5 big pulses, stretched out over about 20 million years. That's a long time for an extinction, but in the big story of Earth, it's still a blink. About 75% of all species disappeared by the end of it. Reefs collapsed again. The armored fish, once rulers of the sea, vanished forever. Trilobites took another blow, shrinking further into survival. Even plants on land were hit. Some types of early trees stopped growing. The world felt unstable, as if something deep inside Earth was out of balance. But what caused it? That's still a puzzle. Some scientists think volcanoes may have played a part. In places like what is now Siberia and Canada, lava spilled out for thousands of years. When volcanoes erupt for that long, they don't just make lava, they fill the sky with gas, carbon dioxide, sulfur, ash. These gases can warm the earth, they can poison the air and the sea, they can block sunlight or trap heat, depending on what they do. Others think the first forests may have helped cause the trouble. Trees pull carbon from the air, but when they die, their roots and leaves rot. That can change the soil, the rivers, and the ocean. Maybe all that new plant life pulled too much carbon too fast, and the earth couldn't adjust. Another idea is that sea levels rose and fell again and again. Each time the water moved, it changed habitats. Creatures that lived in shallow bays were pushed too deep or stranded on dry land. And the oxygen problem, that might have come from all the extra nutrients washing into the sea. Stuff like dead plants and mud from rivers. This feeds algae. When algae die, they sink and rot. The process uses up oxygen. If enough algae bloom, they can choke a sea. But here's the part that makes it all even stranger. The extinction didn't hit everything the same way. Big fish with hard bones vanished. Soft-bodied fish survived. Creatures in shallow warm water died off faster than those in deeper, cooler places. Some groups, like sharks, made it through mostly okay. Others, like placoderms, the armored fish, never came back. Why? No one knows for sure. It's like Earth was testing its creatures, but only some had the answers. And while the oceans struggled, the land became more important. In the middle of all this loss, something amazing happened. A few fish developed stronger fins. These fins turned into limbs. These limbs pushed them onto muddy shores. Slowly, over millions of years, fish became the first tetrapods, animals with 4 legs. These were the ancestors of frogs, reptiles, birds, and even us. So even as the sea life crashed, land life began to grow. This twist is important. It shows how extinction makes room. When one group falls, another rises. The Devonian extinction ended the age of armored fish, but it opened the way for new creatures, lighter, faster, smarter. It cleared the reefs. It changed the air. It broke the old pattern and made space for something new. But still, the Devonian extinction isn't as famous as the one that killed the dinosaurs. It happened slowly, quietly, deep in the sea. Its story is told in dark shale, twisted fossils, and strange gaps in the record. There are places where reefs suddenly stop, then come back millions of years later. There are layers of black rock that show no oxygen. There are dead zones fossilized in time. And just like before, scientists now wonder, was this the 3rd mass extinction, or was it the 4th? If a missing extinction happened before the Ordovician, then everything shifts. The Devonian might not be number 3, it might be number 4 or 5, and that means we might have missed something. Again, each extinction we know about helps us understand Earth's limits. What happens when the seas warm too much? When the air changes? When forests grow too fast? When volcanoes don't stop? But what about the extinctions we don't know? What about the crashes too quiet to see, too old to find, too strange to name? The Devonian shows us that even a slow fall can be deadly. It shows that extinction doesn't always roar. It can creep. It can come through algae blooms, rising heat, and falling oxygen. It reminds us that life is strong, but not unbreakable. And it whispers that there may be more stories like it, buried deeper still. stories we haven't uncovered, chapters we haven't read yet. The land was changing again. The Devonian had ended with a slow fall into silence, but now, the Triassic period was just beginning to speak. New plants grew in strange shapes. Ferns unfurled beside tall trees with scaly bark. Strange reptiles crawled across dry plains. The oceans had calmed, but they were different now. Coral reefs were not as strong. Fish were not as many. The sea floor looked empty in places where it once teemed with life. And on land, something new was stirring. Tiny creatures with long legs and sharp teeth began to roam. They were fast, light, their eyes pointed forward. They could hunt. It was the dawn of the dinosaurs, but they did not rule the world yet. The earth still belonged to other animals. There were big reptiles that looked like thick-bodied lizards, and others with beaks like turtles. There were strange, long-necked swimmers in the seas, and the skies had only just begun to see the first thin-winged flyers. Life was rebuilding again. But deep beneath this new life, the planet was rumbling. The surface looked calm, but the core was restless. A massive crack was forming. Soon the Earth would break open. This next extinction, the Triassic-Jurassic extinction, came fast and hard. It happened around 201 million years ago. Scientists believe that giant volcanic eruptions were the main cause. These eruptions weren't just big, they were huge beyond anything in human history. They stretched across what is now the Atlantic Ocean. Lava poured out in thick sheets for hundreds of miles. It didn't just last days or weeks. These eruptions kept going for thousands of years. The lava built new land, but it also filled the air with gases. Carbon dioxide shot into the sky. So did sulfur and ash. The skies darkened. The air grew hotter. Rain turned acidic, burning plants and washing poison into the rivers. Oceans began to lose oxygen again. Coral reefs started to fade. As the atmosphere changed, so did the balance of life. The big reptiles that once ruled the land began to die off. Many kinds of amphibians, once strong, vanished completely. Creatures that could not handle the heat or breathe in low-oxygen water didn't stand a chance. What makes this extinction even more frightening is how quickly it happened in the rocks. One layer shows a world full of variety. Then, a few inches up, that variety is gone. Whole groups of animals disappeared between those thin layers of mud and ash. It's like the lights of a theater going dark between one act and the next. No warning, no noise, just quiet. And when the lights come back on, the cast has changed. This loss made room for something new. The dinosaurs, once small and pushed to the edges, began to rise. They survived where others did not. Maybe it was their eggs, which could be buried and protected. Maybe it was their lungs, which worked better in hot, thin air. Whatever the reason, they took the chance. In the space left behind, they grew taller, longer, stronger. They became the giants of the next age. But the Triassic extinction didn't just help dinosaurs. It changed everything. In the sea, marine reptiles replaced the old fish. On land, new kinds of insects and plants spread across the continents. In the sky, the first real flyers began to glide. Even the soil changed. Forests grew where none had been before. Swamps dried up. Deserts spread. The earth rearranged itself. The proof is still written in stone. In places like Nova Scotia and Morocco, you can find the rocks that show the change. Before the extinction, there are footprints of many different animals pressed into mud that hardened like clay. After the extinction, the footprints are simpler, fewer kinds, more dinosaur tracks. In between there are layers of ash and dark rock rich in volcanic minerals. These layers are like scars on the planet's skin. And it wasn't just life that changed. The very shape of the Earth shifted. At this time, all the land was still joined together in one giant supercontinent called Pangaea. But the cracks from the volcanic eruptions began to pull it apart. The land split, new oceans formed. The continents began to drift toward the spots they are today. The extinction didn't just reset life. It helped redraw the map of the world. The question, again, is simple but deep. If this is the fourth mass extinction, what came before it? If we've already missed one early extinction before the Ordovician, how many other stories are buried even deeper? The Triassic extinction is well studied. We can see it, measure it, date it. But how many others might we not see at all? Are there mass extinctions hiding in places with no fossils, no rocks, no signs? Could the Earth have wiped the slate clean more times than we know? Every extinction so far had its own shape. The Ordovician came with ice. The Devonian came with slow drowning. The Triassic came with fire. The world burned, then broke apart. Life nearly collapsed again, but each time it came back. Not the same, never the same, but it came back. New animals, new rules, new kings. That's the lesson, again and again. Life is tough, but the earth is tougher. It has the power to end entire ages, and the clues it leaves behind are thin. A dark layer in the rock, a missing kind of shell, a shift in fossil teeth. That's all we have. That and the space between. The Triassic extinction is real, counted, named, but even it raises new doubts. Because if lava and gas could end a world once, could it happen again? Could something deep inside the earth wake once more? And if it did, would we know in time? Every act builds the story. Every extinction is a doorway. The Triassic was one of the biggest, and one of the quietest, not as famous as the one that ends the dinosaurs, but just as deadly, and without it, we might never have known the name dinosaur at all. The world turned again. New giants would rise, but the shadow of the past never left. It's still there, under every rock, behind every fossil, and deep in the cracks where the earth once burned, waiting. The age of dinosaurs had begun. After the Triassic extinction cleared the land, the survivors stepped into a world of open space and rising heat. The ground was firm and dry, with wide deserts and deep rivers winding between tall, fern-covered forests. The air was thick with buzzing insects, and strange calls echoed through the trees. Dinosaurs were small at first. Some walked on 2 legs, others on 4. Some were meat-eaters with sharp teeth and claws, while others chewed plants with strong, grinding jaws. They moved across the land in silence, hunting, hiding, and growing. Over time they changed. Some grew massive necks and tails and stretched as long as a school bus. Some stood taller than a house, their feet shaking the ground with every step. They ruled the land, the sky, and even the shallow seas. This was their time, but their time would end. For over 130 million years, the dinosaurs spread across the planet. In the air, flying reptiles soared. In the oceans, giant swimming creatures with long teeth and fins hunted for fish and squid. Volcanoes were quiet now. The climate stayed warm. There were no ice caps. Forests of conifers and ferns stretched across the continents. Flowers had just begun to appear. Tiny mammals scurried underfoot, mostly hiding from the giants above. Birds, the feathered cousins of dinosaurs, flew from tree to tree. It seemed like life had finally found balance. But far above Earth, something cold, fast and deadly was moving through space. It began with light, a bright streak in the sky, a flash that outshined the sun. Then came the roar, not thunder, but something deeper, a sound that cracked the sky and split the air apart. The asteroid struck with more power than all the volcanoes on Earth combined. It hit near what is now the Yucatan Peninsula in Mexico. The asteroid was over 6 miles wide, but its blast affected the whole planet. The shockwave flattened forests thousands of miles away. Oceans surged with waves taller than buildings. The air caught fire. Winds screamed across the land at hundreds of miles per hour. Ash, dust, and vapor rose into the sky and wrapped the planet in darkness. This was the Cretaceous Paleogene extinction, also called the KPG extinction. It happened 66 million years ago. In only a few hours, the world changed. Fires burned across continents. The sky turned black, blocking the sun. Without sunlight, plants could not grow. The temperature dropped fast. It was like winter, but not for one season. For months, maybe years, cold air swept across lands that had never known snow. Rain became acid. Food ran out. And then, one by one, the great creatures fell. The dinosaurs could not survive. Without plants, the plant-eaters starved. Without them, the meat-eaters followed. Giant flying reptiles disappeared from the sky. Ocean life also suffered. Tiny plankton died when sunlight vanished. With the plankton gone, bigger sea creatures had nothing to eat. Coral reefs crumbled again. Marine reptiles vanished. Nearly 75% of all species on Earth went extinct. It was one of the most violent endings life had ever known. But not everything died. Some animals, small and lucky, found shelter. Mammals hiding in burrows or caves survived. Crocodiles, turtles, frogs, creatures that could live in water or wait out the cold, made it through. Some birds also lived, flying above the ashes, finding seeds or insects to eat. These survivors would shape the world to come. After the darkness lifted, Earth was quiet again. The forests were blackened, the skies were grey. The mighty dinosaurs were gone. Their bones lay scattered across the land. The world waited, still and strange, for new life to rise. And slowly it did. Mammals began to grow. First, just a little, then more. They took over the empty spaces. They explored the forests. They ran, climbed, and dug. They began to form new shapes, some small and quick, others large and strong. Whales returned to the sea. Monkeys swung through trees. Horses galloped across wide plains. And one day, much later, one kind of mammal learned to speak, to build, and to wonder. The asteroid that ended the dinosaurs also made space for something new. Just like the extinctions before, it reset the story. It erased old rulers and allowed new voices to rise. But this extinction was different too. It left a mark we can still see. In rocks around the world, there is a thin layer of clay. Inside that clay are tiny bits of iridium, a rare metal more common in space than on Earth. This is the fingerprint of the asteroid. It's found in places as far apart as North America, Europe, and Asia. It proves that something came from the stars and changed the world below. Scientists have studied the crater, the rocks, the fossils. They have measured the temperatures, the ash, the soot. Everything lines up. The story is clear. The dinosaurs did not fade away. They were ended by an event so sudden, so sharp, that life itself almost failed. And yet, even in that disaster, there was hope. From that silence, life began again. This fifth extinction is the most famous. It fills books, museums, and movies. Children know the names: T-Rex, Triceratops, Velociraptor, but few know the full weight of their end. Few feel the silence that followed. Fewer still ask, what if this wasn't the fifth? What if the list is longer? What if this story has been told before, just in ways we haven't yet found? Because if an asteroid can do this, what else could? Could other crashes have come before, leaving behind only quiet layers of rock? Could volcanoes, oceans, or even strange changes in the air have ended worlds we never knew existed? We count 5 extinctions, but maybe there are 6 or 7. Maybe we've only read the pages that survived. And now, we look around, at forests, skies, and seas filled with life once more, at birds, who are all that remain of the great dinosaurs, at mammals, who rose from shadows to rule the day, at ourselves. And we wonder, not just what ended the dinosaurs, but what might end us. Because the asteroid came without warning, and if it happened once, it could happen again. The Earth has turned through billions of years. It has seen giants rise and fall. It has burned, frozen, flooded, and cracked. 5 times, it nearly lost all life, or maybe 6, or more. The rocks remember, the fossils whisper, and the next act is always waiting. The list was supposed to stop at 5 times when life nearly ended. 5 mass extinctions, 5 giant cuts in the story of Earth. That's what the books said. That's what the charts showed. 5 bold lines, 5 names, but science is not a book with a clear ending. It is a trail of questions, and sometimes, questions don't stop where we think they should. In recent years, scientists have looked closer at the rocks, the fossils, the layers of time, and found something strange, something that doesn't fit, a silence, a gap, a missing piece, maybe even a 6th extinction. To find it, you have to go back, farther back than the dinosaurs, back past the trilobites, past the armored fish and the coral reefs, back to a time before the first big extinction on the list, before the ice of the Ordovician, back to the Cambrian and the times just after. This was a time when life had only recently exploded in size and shape. Soft-bodied animals with strange parts and eyes were swimming through warm, shallow seas. Some had shells, some had spikes, some looked like nothing alive today. Fossils from this time are rare but strange. They show a world full of new life, full of possibilities. Then, suddenly, many of them are gone. It's not counted among the 5. There's no official name, but there's a change, a deep one. In some places, whole groups of creatures disappear from the rocks, not just a few species, but entire families. Trilobites lose their variety. Brachiopods shift in shape and size. The strange creatures from the Burgess Shale and other famous sites vanish without a trace. It looks to some scientists like another extinction, a hidden one, not because it was small, but because it happened so long ago, and in ways we can barely measure. The layers of rock from this time are not always clear. There are missing pieces, parts that were never preserved. Soft creatures don't fossilize easily. If they die without shells or bones, their bodies vanish in days. Only in special places, with perfect mud and no oxygen, can their shapes last through time. That's why we know about some of these early creatures at all, because of lucky finds, frozen in black stone. But where those perfect places don't exist, the story disappears. And that's where the trouble begins, because if the rocks are quiet, how do we know what really happened? Still, clues remain. One clue is in the oxygen levels. Around 500 million years ago, oxygen in the ocean dropped, not everywhere, not all at once, but enough to matter. When oxygen goes down, life struggles. Some creatures can handle it, others cannot. The ones that need clean, moving water, like corals, trilobites, and certain worms, begin to vanish. In the rock record, their fossils drop sharply. Then come black shales, layers of rock that form in dead zones, where the ocean was still and low on oxygen. The pattern repeats in many places around the world. First rich fossils, then silence. Another clue is in the types of animals. Before the gap, creatures are wildly different. After, they seem more familiar, more normal, in a way. More like the kinds of sea life that fill oceans today. Some scientists wonder if the early weird ones were wiped out. Not slowly but fast. Too fast to leave a long trail. Too fast to adjust, like the later extinctions, where pressure builds quietly, then crashes all at once. But what could have caused it? There are no clear signs of asteroid impacts from that time, no craters, no iridium layers, and while volcanoes could be part of the answer, the evidence is faint. Some point to the growing amount of plant life in the sea. Tiny photosynthetic organisms began to change the chemistry of the water. They pulled in carbon, they pumped out oxygen, but not always in a helpful way. In some cases, their growth may have led to massive algae blooms. When these blooms died, they sank. As they decayed, they used up the oxygen. The result, lifeless seas, stretching for miles. Sea level also changed during this time. The ocean rose, then fell, then rose again. Each change pushed animals into new places, or trapped them. Creatures used to warm, shallow water might suddenly find themselves in deep, dark zones. Some could adapt, most could not. And with every swing of the sea, more life was lost. The truth is, no one knows for sure. That's why it's not on the list of 5. That's why it doesn't have a name yet. It's a maybe, a shadow, a whispered warning in the rocks. But the signs are there, in the sudden shift in fossils, in the black layers, in the missing forms, and in the rise of new types ready to take their place. If it was an extinction, it might be one of the most important, not just because it happened early, but because of what came next. The animals that survived it went on to shape the world. They formed the backbone, literally, of all that followed: fish, amphibians, reptiles, birds, mammals, us. If the strange creatures of the early seas had lasted longer, Earth might look very different. We might never have arrived. So this possible 6th extinction, this hidden one, may have written the rules for everything else. It may be the reason we are here. And that changes the story. It means the count may be wrong. It means 5 isn't the full number. It means the danger came earlier, and maybe more often than we thought. And if we missed one, how many more have we missed? How many quiet collapses lie between the lines? How many ancient deaths are waiting to be counted? This is why scientists dig, scrape, scan, and search, not just to study what lived, but to understand what died, and why. The Earth has always carried secrets. Some are locked in ice, some buried under lava, some are hidden in layers of mud, no thicker than a fingernail. But when we read the rocks closely, we find things we never expected: a drop in oxygen, a strange shift in shape, a hole where there should be noise. And those gaps might be more than accidents. They might be signs. Signs that mass extinction is not rare, that it is not just 5, that it might come more often, more quietly than we ever imagined. And if that is true, then we must look harder, listen closer, count again. Because somewhere in the silence, the 6th extinction may already be calling. Beneath a quiet hill in southern China, there is a wall of black rock. It looks like any other cliff, dry, dusty, streaked with lines. But if you stand very still and run your fingers across one of those lines, you are touching the edge of everything. That thin layer, barely the width of a fingernail, marks the worst day life has ever seen. A moment when the story almost ended, not just for a few animals, but for nearly all of them. A moment that came long before the dinosaurs, long before flowers, long before wings or fur or leaves. This was the Permian-Triassic extinction, the Great Dying, and for a long time no one even knew it had happened. It began slowly. At first, the world looked fine. The land was warm and dry. Huge reptiles walked across red deserts. In the oceans, fish swam between coral towers, and trilobites still crawled along the bottom. Thick forests of tree-like plants covered the swamps. Insects buzzed through the heavy air. Everything seemed normal, but deep below the surface, pressure was building. Under what is now Siberia, the earth cracked open. What came out wasn't a single blast. It wasn't like the asteroid that would one day fall on the dinosaurs. This was slower, but even more dangerous. For over 1 million years, volcanoes poured lava onto the land. Rivers of fire spread out across an area larger than the United States. The air filled with smoke and ash. But the real danger wasn't just heat. It was gas. Tons and tons of carbon dioxide and methane were released into the sky. The planet began to warm, and it didn't stop. Rain turned acid. Oceans absorbed the carbon and became more like vinegar. Coral reefs dissolved. Shells grew thin. Oxygen levels in the sea dropped until the deep turned deadly. Whole layers of water became toxic. Hydrogen sulfide gas bubbled up from the ocean floor, killing everything in its path. Even the skies turned greenish-grey. The air smelled like rotten eggs. Forests dried and burned. Rivers dried into dust. Life, which had once filled the land, the sea, and the air, began to vanish. In the end, 90% of all marine species were gone. On land, 70% of animals vanished. The trilobites, who had survived for 270 million years, disappeared forever. Many kinds of insects were lost. Plants with thick trunks and fern-like leaves gave way to smaller, weaker ones. Even microbes changed. The world went quiet. Fossil layers from this time are almost empty. Where there had once been a crowd of life, now there was silence. It took millions of years for life to return, and when it did, it looked different. The survivors were few. Some were lucky, some were tough. Some could live in low oxygen, some could eat almost anything. These were the rules now, not strength, not size, just endurance, just the ability to hold on. One of the strangest things about the Great Dying is how little was left behind. There is no single fossil that says, this was the end. There is no giant tooth or broken bone that explains it all. Instead, there are tiny clues. A drop in carbon in one layer, a spike in sulfur in another, charcoal in rocks that once held roots, fossils of creatures curled up like they were trying to escape, empty layers, quiet stone. For a long time, scientists didn't even know this extinction had happened. It wasn't until the 20th century that someone noticed the missing fossils in rock layers across the world. They noticed the same sudden drop, the same dark stone, the same strange silence, and slowly, the picture came into focus. This wasn't a small change. This was the worst thing that ever happened to life on Earth. But still, questions remain. Was it only volcanoes that caused it, or did something else add to the damage? Some scientists believe that a burst of methane from the seafloor may have made the warming even worse. Others wonder if changes in Earth's orbit may have helped start the heating. There are also hints that a small asteroid might have hit during that time, adding more heat and dust. The answer is likely a mix of many things. A planet already on edge, pushed too far by fire and gas. The Permian extinction didn't just erase life, it reset evolution. Before it, animals had sprawled legs like lizards. After, the survivors began to stand taller, legs under their bodies, like the dinosaurs that would one day rise. New plants, new insects, new fish, all different from what came before. The world had been wiped clean. Now, it was starting over. And what makes it all even stranger is this. If there was a sixth extinction before the Ordovician, then the Great Dying wasn't the third, it was the fourth. And if we've missed one, could we have missed more? Could the worst event in Earth's history be just one of many? Could there have been other collapses just as big, just as silent? The rocks still whisper secrets. In places where the land folds and cracks, you can sometimes find thin bands of clay between thick layers of stone. These are the pauses in the story, places where something stopped, something broke. We know the 5, we wonder about the 6th, but maybe there are more. Maybe the Earth has cleaned its slate more times than we dare imagine. The Permian extinction was not a warning. It was too early for that. There were no eyes to see it, no voices to tell it. But now we can read the rocks. We can count the missing. We can measure the gases and the heat. And we can ask, what would it look like if it happened again? Because the forces that ended the Permian are still here. The planet still has volcanoes. The oceans still warm. The skies still trap carbon. And we, now walking the land, shaping the seas, building in stone and steel, we are not immune. We are part of the story, a chapter not yet finished, and the quiet layers that follow us have not yet been written. It begins with a beep, a soft blinking signal in a quiet lab. A scientist leans closer, eyebrows drawn tight. She clicks a few keys. On the screen, a line of data glows red. The reading is too high, not by much, but enough to make her stop chewing her gum. She runs the numbers again, still red. Then she sends it to her team. Around the world, other labs check their instruments, and slowly a pattern forms. The oceans are changing, the air is changing, the Earth is warming again. Not over millions of years, but right now, fast, faster than any time in the fossil record. And somewhere in the shadows of that data, a terrible question waits. Is this the beginning of mass extinction number 7? For years, people thought the danger was far away, something for the future, something that would not touch them. But the signs are now too loud to ignore. Coral reefs are bleaching, turning white like bones. Forests are burning. Insects are vanishing in silence. Birds fall from the sky in places where the wind once carried their songs. The Arctic melts and turns blue. Glaciers shrink. Sea levels rise inch by inch, swallowing coastlines. Strange heat waves twist across continents. Storms grow larger. Rain falls where it never used to. Drought cracks the land where rivers once flowed. It is not a volcano, not an asteroid, not a sudden blast. But it might be something worse, because this time, the cause is us. The Holocene extinction, some call it the Anthropocene extinction, is not official, not yet. But the list of lost species keeps growing. The golden toad, the Baiji dolphin, the western black rhino, gone. Many more are close behind. It is happening slowly, like a clock ticking down, and also quickly, like a match burning through paper. In just a few hundred years, humans have reshaped the Earth in ways that once took millions. We've cut down forests that stood for centuries. We've poured carbon into the sky, more than any volcano ever did. We've warmed the oceans, melted the poles, and changed the very chemistry of rain. We've built walls, cities, roads and fences that block the paths of ancient migrations. We've emptied rivers. We've overfished seas. We've broken the web of life strand by strand, not on purpose, not with evil in our hearts, but with speed, with machines, with hunger for more. And now, animals are disappearing faster than they can evolve. Plants lose their homes as the climate shifts around them. Pollinators vanish. Seeds go unspread. The web frays. It weakens. Every loss makes the next loss more likely. And at the center of it all stands one species. Us. People dig into the past to find out how bad things have become. They compare today to the 5 mass extinctions. They look at speed, scale, and spread, and they find something chilling. Today, species are vanishing up to 1,000 times faster than normal. Whole groups of animals, like amphibians, are in sharp decline. In some places, 90% of insects are gone. The oceans have more plastic than fish in some areas. Tiny bits of it float in the air, inside clouds, inside us. What's worse is that this extinction doesn't feel like one. There's no single day, no big boom, no sudden smoke cloud. The sun still shines, grass still grows, birds still chirp, some of them, but the numbers shrink each year. The spaces grow quieter. A child born today may never see a wild elephant, may never hear a frog's croak from a pond at night, may never watch fireflies dance in the dark. This is the extinction you don't see until it's already done. But we are different. We know how to read the rocks. We've learned the stories of the 5 that came before. We know what causes collapse, volcanoes, warming, ocean acid, oxygen loss. We know what life needs to survive, and now we can measure the danger as it grows. This time, we are not blind. This time, we have a choice. The trouble is, we also have power. Great power. Power to drill, dig, burn, cut, build. and power to save, to protect, to pull back, to restore. Some call this a tipping point, a time when the future can still change. Others call it the point of no return, a fall already begun. What's clear is that Earth is reacting, not with rage, but with shifts, with heat, with floods, with whispers in the data. It's not just about the animals anymore. It's about food, water, air. It's about us. What will the world look like in 100 years? 500? Will our cities crumble into ruins as forests return? Will our satellites fall quiet and birds fill the sky again? Or will the list of vanished creatures end with our own name? The answer depends on what we do now. Some people are trying. Scientists grow frozen seeds. They track animal movements. They plant forests, clean rivers, build coral nurseries. Young people march in the streets. Some countries sign laws. Some companies change paths. But the work is big, the clock is fast, and the Earth does not wait. This moment may one day be studied in rock. A thin line of plastic, a spike in carbon, fossils of cows and cats and concrete, and maybe, just maybe, a sudden silence at the top, the mark of another fall. But it doesn't have to end that way. The sixth extinction, if this is it, is still being written. It is not yet finished. It is not yet sealed in stone. We still have voices. We still have tools. We still have time, though not much. What makes this extinction different is not just its cause, it's the fact that we are here to see it, to feel it, to stop it, or to let it continue. The other 5 came with no warning, but this one has been blinking, beeping, shouting from data and news and storms. The Earth is speaking, the animals are fading, the future is tilting. And we are the only ones who can choose what happens next. A quiet museum hallway, dim lights, walls of stone, glass boxes line both sides, each one holding the remains of something that once lived, a trilobite curled in ancient mud, a branch from a tree long turned to coal, a tiny jawbone from a creature no bigger than a mouse. A model of a Tyrannosaurus looms over a group of school children, frozen mid-roar. Their teacher's voice echoes off the smooth floor, soft but steady. These are what was left behind, she says, pointing to a long tooth. But the most important part is what wasn't. The boy in the second row frowns. He presses his hand to the cool glass, stares at the fossils behind it. His breath fogs the surface. His eyes trace the line of a fish skeleton, perfectly preserved, every bone in place. Then he looks up. How do we know there weren't more? He asks. Ones we missed? That question, that simple question, hangs in the air like dust in sunlight. The guide smiles politely, but she doesn't answer. In a lab across the world, another group of people is trying to, not with guesses, with lasers, with computers, with drills. These scientists are digging into the smallest spaces, searching for clues left behind, not in bones, but in the chemistry of the Earth itself. They study tiny bubbles trapped in crystals, thin lines in ice cores from Antarctica, dust samples from the ocean floor. Each layer is a sentence in the planet's story. Some chapters are loud, full of teeth and flame. Others are nearly silent. But they sip to there. One geologist kneels beside a slice of rock, no bigger than a book. It's from deep underground, near a site in Namibia. She wipes the dust away and places it under a microscope. What she's looking for isn't shape or color. It's a sudden shift in carbon, a strange drop. It means something happened, a change so sharp it left a fingerprint in stone. Maybe it was a bloom of bacteria, maybe a chemical spill in the sea, maybe the sky darkened for months. She doesn't know what caused it yet, but the pattern matches others. Other places, other rocks, other times, ones with fewer fossils, ones with too little oxygen, ones that look like the start of an extinction. In Brazil, a paleontologist studies a cave wall, running a fingertip across a sharp line where the color changes from light to black. That change took thousands of years, maybe less. In that shift, fewer bat fossils appear, fewer bird bones, insect remains drop. The guano layers thin. What happened? The air? The water? Did something go wrong with the cave's ecosystem? Or was it a clue to something wider, something global? In Germany, a team scans a limestone quarry, layer by layer. A radar image flashes on their screen. They see a smooth sequence of sediment, then a sudden rough patch. The shapes of the minerals are different. The texture, almost broken. Above that, fewer fossils, Below, a rich field of shells and coral. It's like turning a page and finding most of the words missing. This is the mystery they face. Extinctions are not always loud. They are not always meteor strikes and lava floods. Some are slow, some are quiet, some leave almost nothing. A single spike of sulfur, a strange tilt in isotopes, a missing pattern of shell shapes. These are not things you see in a museum display, but they are just as important. More scientists are starting to believe that we may have missed some of Earth's mass extinctions, not because they were small, but because they were silent. They think there may be as many as 10, maybe more. Some might have lasted thousands of years, some just a few centuries. Enough time for life to rise, change, crash, and rise again, but without enough bones, without enough noise. And if that SIP's true, it changes everything. It means life is even more fragile than we thought. It means the 5 we know, the famous 5, are just the tip of the story, that the history of life is not a smooth line, but a rough road full of potholes and cliffs. That species don't just fade away at a slow pace. Sometimes they vanish in bunches, and we don't see it coming. A new computer model spins on a lab screen in Sweden. It shows a digital Earth, oceans, continents, wind, heat, life. A slider ticks forward through time. As carbon levels rise, tiny creatures in the sea begin to fail. Then bigger ones. The model flashes red. A domino effect begins. The sea goes quiet. On land, plants suffer. Insects fall. Birds follow. It's not a prediction. It's a test, one based on what happened before. One that shows how a small push can lead to a massive fall. The room is quiet as the screen turns black. Back in the museum, the teacher answers the boy SIP's question at last. She kneels beside him, her voice calm and kind. "We don't SIP know for sure," she says, "but we SIP still learning. Every rock, every fossil, every layer we study teaches us more. There may have been others." The boy nods. He SIP's not afraid. He SIP's curious. As he walks away, the camera lingers on the fossil in the glass. A perfect shape, a silent shell, just one clue in a puzzle that may never be finished. But scientists will keep digging, keep testing, keep asking, because the Earth has many voices. Some shout, some whisper, and some are so quiet, we have to listen with tools, not ears, with lasers, not eyes, with questions, not answers. Because if mass extinction can hide in rock and dust and air, then what else is waiting to be found? A single red dot blinks on the screen, then another, then 10 more. A satellite floats high above the Earth, its silver panels gleaming in the sunlight. It spins slowly, watching, measuring. The screen fills with numbers, temperature readings, ice thickness, sea level rise, all of them climbing. A man in a dark room leans forward. He adjusts his glasses and stares at the data. It's not just heat anymore, it's patterns. Patterns that match ancient warnings. Patterns pulled from deep inside rocks and coral and frozen mud. Patterns that speak of extinction. Far below, the Earth is alive with movement. Planes streak across the sky. Cars crawl like ants across concrete veins. Cities sparkle under clouds. Lights never turn off. Machines hum, phones buzz, and everything seems normal. But deep in the forests, fewer birds sing. On the reefs, more coral bones bleach white. The balance is tilting. In a classroom, a girl opens a science book. On the page is a picture of Earth's 5 mass extinctions. She traces them with her finger: Ordovician, Devonian, Permian, Triassic, Cretaceous. A 6th is missing, a blank space. Her teacher says the list is not finished yet, that it might be growing, that it might soon have a new name. The girl stares out the window. It is raining again, hard and sudden. Even though it's not the rainy season, the sky looks wrong, grey, heavy, strange. In the ocean, a whale dives deep. The water is warmer than it should be. The currents are weak, the food is low, the whale sings, but fewer voices answer. On the seafloor, layers of dead plankton settle like snow. Above them, plastic floats like jellyfish. The sea is still wide, still deep, but something inside it is broken. Tiny things are dying, and with them, everything else begins to shake. And then, there are the cities. Bright towers, humming lights, rows of windows. People walk through them, eyes on screens, feet on stone. They buy, they eat, they build, but some begin to notice cracks. Strange weather, sudden floods, fires in the hills, storms that stall. Crops that fail, bees that vanish, fish that don't return. It feels like something is slipping out of place. Scientists gather in a hall, quiet and tense. Charts on the wall show extinction rates. Arrows point up, circles shrink. One graph has a red line. It curves steeply, dangerously. At the top it reads Biodiversity Loss, 2025. A woman stands and clears her throat. We are not just seeing change, she says. We are seeing collapse, a quiet fall. Her voice is calm, but the room feels heavy. No one claps. No one smiles. They all know what the data means. In the background, the earth keeps turning. Day becomes night. Seasons pass, but the rules are different now. The old balance, the slow dance of life and death, of rise and fall, has been pushed. The planet is wobbling, like a spinning top about to tip, and no one knows if it can right itself in time. Some people act. They plant trees, clean rivers, protect forests. They talk to their neighbors, build wind farms, fix broken laws. Others feel lost. They scroll, read, worry, but don't know what to do. Some deny it all. The earth has always changed, they say. It'll be fine, but deep down, even they feel the tremble. The earth does not scream. It does not beg. It just changes. Slowly at first, then fast. Just like it did during the Great Dying, just like it did after the asteroid. The difference now is the mirror, the reflection. Because this time, the cause looks like us. Back in the museum, the boy from before stands before a new exhibit. It's not about the past. It's about the present. A screen shows videos of glaciers cracking, forests burning, frogs going silent. A chart scrolls beside it, showing species after species marked endangered, then extinct. He watches quietly, his hand pressed against the glass. His face reflects in the screen. He looks at himself, then at the numbers, then back again. Outside, the wind picks up. A strong gust rattles the windows. Rain begins to fall again, thick and hard, bouncing off the sidewalks. People pull their coats tight. Umbrellas bloom like flowers in the wind. Somewhere, a dam breaks. Somewhere, a hill slides. Somewhere, the last of a species disappears into silence. But the story is not over. Not yet, because there are still choices. Still time. Not much, but enough to bend the path. The girl in the classroom closes her book. She looks at the blank space where the sixth extinction would be. Then she flips to the back. There's a section called Possible Futures. In it she sees pictures of cities filled with green, of animals returned to old homes, of rivers that run clean, of people working together. It's not a promise, just a chance. In the lab, the red dots stop blinking. They turn yellow, then green. One of the scientists smiles. It's a model, a simulation, but it shows something new. A path that bends, a future that doesn't fall. He knows it's only one version, but it's enough to keep going. The Earth is not done. It is old, wise, full of scars and secrets. It has ended worlds before, but it has also made them, given life, taken it, and given it again. The question is not what the Earth can do. The question is what we will do. Because mass extinction is not just a number. It's a shadow, a warning, a mirror. And this time, it's looking back at us. The desert stretched far in every direction, flat and dry under a pale blue sky. The heat shimmered over the rocks, making the air dance. In the distance, a tall metal pole stood straight up from the ground, holding a small spinning fan and a blinking light. Beside it, a group of scientists moved slowly, wiping sweat from their necks and checking screens. They weren't looking for animals. They weren't searching for fossils. They were listening to the air, the dust, the quiet. Something deep inside the earth had changed again, and they were trying to catch it. They had come here because of a whisper in the data, a thin signal, a strange shift in pressure under the ground, just like the ones that had happened before the biggest extinction events in Earth's past. Not loud, not violent, but steady and spreading. They didn't say the word out loud, not yet, but they all knew what they were thinking. Could this be the first sign of number 7? Far away, in a snowy valley near Iceland, another team had seen something strange. A glacier that had never cracked before, now groaned loudly, like an old tree falling. Steam poured from the ice, and when they dug down, they found warm stone beneath. Not just warm, hot, hotter than expected. They checked the old maps. This wasn't supposed to be a volcano, but something was moving down there. Something alive. In the ocean, another signal came. The water near Tonga had turned cloudy. Fish were fleeing. A research sub sent pictures of dead coral, split open like broken glass. Sulfur bubbles streamed up from the cracks in the sea floor. One of the scientists watching the screen whispered, "It's waking up." One of the scientists watching the screen whispered, "It's waking up." It didn't make sense. These signs were far apart. A desert, a glacier, a deep ocean trench. But when the data was lined up, the pattern was clear. Something was rising from below. In the quiet of a library, a young woman studying old extinction events saw the same thing. She stared at graphs, lines of temperature, CO dulls. She compared them to fossil layers from the Permian and the Triassic. Then she added in the data from today, and her hand trembled. The curve was almost the same, not exact, but close enough to make her feel cold. Meanwhile, in the city, life went on. Cars honked. People shopped. Kids laughed in parks. No one noticed the tiny tremor that passed under the pavement at 4:03 p.m. Just a soft jolt, a blink, then gone. But somewhere, deep down, a crack had grown by 2 inches. Back in the lab, the computers ran all night. They compared ancient events to modern ones. The volcanism that ended the Permian had released trillions of tons of CO2. Today, humans had done the same, but in just 2 centuries. The scientists looked at each other. No one wanted to be the first to say it, but finally someone did. If we add one more blow to the system, even a small one, we could trigger a runaway effect. Like in the past, like before the Great Dying. That's when they started calling it the silent trigger. Not a meteor, not a blast. Just one more thing, one extra push. A burst of methane from melting ice. A volcano waking in the wrong place. An ocean current that stopped too soon, and the whole system could fall. Fast. One scientist looked at the map of weak zones across the planet. He saw something in the center of it all. The mid-Atlantic ridge where the Earth's crust is splitting open. The same place that had cracked wide open during the Triassic extinction. Lava had poured out then, changing the air and sea. Now it was rumbling again. On a ship above that ridge, a team lowered a long metal probe into the sea. It took hours to reach the bottom. When it did, it found something unexpected. The rock was new, shiny, warm to the touch. And beside it, a field of dead worms. Not fossilized, fresh. The camera panned slowly, showing the dead packed together. No signs of disease, just gone. The ship's captain didn't speak. He just turned away from the screen. In the air, satellites picked up strange waves, heat signatures rising from spots that had been cold, forests blinking red in patterns, animals moving in odd ways, birds flying earlier, turtles nesting in strange places. Something was pulling at the base of the web. And then the news came. A lake in Africa had turned green overnight. Fish floated on top. People nearby had gotten sick. Scientists rushed to test the water. It wasn't poison. It was gas. A loess had risen from deep below and suffocated everything in the area. Just like the deadly lakes from millions of years ago. Just like the signs before other mass extinctions. The world started to listen. Not everyone believed. Some called it fear, others called it fiction. But the ones watching the data knew better. The pattern wasn't stopping. It was speeding up, and the clues from the past were now warnings for the future. The 5 known mass extinctions had one thing in common. A tipping point. One small thing that became the final push. And now, the push might already be here. The scientists gathered in a quiet room. No reporters, no flashing cameras, just numbers on screens. They looked at the models, at the simulations, at the growing tremors. The leader spoke softly. "We don't know if this is the start," she said, "but it's close enough that we have to act like it is." Some began to write emergency reports. Others reached out to global leaders. A few just sat, stunned. Outside, the earth turned. Clouds passed. The wind blew. The cracks deepened. A boy stood at the edge of a dry riverbed. He picked up a rock, smooth and cool. He didn't know it yet, but that rock was sitting on top of a new layer. One that future geologists might one day name. One that might mark a fall, or a change. He tossed the rock. It bounced twice. Then silence. And above him, the sky held its breath. The sun had just begun to rise, painting the hills with gold, when the paleontologist knelt beside a wall of stone. Her gloved hand brushed gently over the rough surface. She wasn't looking for a giant dinosaur bone, or the curve of a mammoth tusk. She was looking for something far smaller. Tiny shells, single grains of ancient life pressed between layers of time. The wall in front of her wasn't tall, maybe 2 meters high, but it held millions of years of Earth's memory. Each stripe of color marked a different world, a different age. Some layers were thick and full of shells, bits of coral, signs of life everywhere. But then came a thin, dark band, only a few centimeters wide. No shells, no bones, just black rock, cold and silent. That was what she came for. Her tools were small, a brush, a hand lens, a notebook, but her eyes were sharp. She leaned in close, watching the stone. There it was again, that strange boundary, just like the ones seen in other parts of the world. South China, Morocco, Nevada. The same thin band, always dark, always quiet, always missing life. It was like a scar running through the Earth's history. That morning, she took a sample and placed it in a clear bag. Back at the lab, she studied it under a microscope. The grains were fine, the carbon levels were high. The oxygen markers had dropped suddenly. That meant something big had happened, something fast. The kind of crash that kills not one species, but many. It looked like a silent extinction. She wasn't the only one who had seen it. Other scientists had found the same black line. It wasn't famous like the layer left by the asteroid that killed the dinosaurs. It didn't have shocked quartz or space dust, but it had its own signal, a quiet warning written in mud and ash. That black layer marked a strange time in Earth's story, about 500 million years ago. Back then most life lived in the sea. There were trilobites, floating worms, early fish, and spiny creatures with no names. And then, suddenly, many were gone. Not all at once, not with fire or ice, but in waves. Populations shrank. Food chains snapped, reefs collapsed. New fossils replaced the old ones, but only above the black line. The question now was what caused it. Some thought it was sea level. The ocean had dropped fast, exposing shallow areas where much life had lived. Then the water came back just as quickly. That kind of whiplash can wipe out entire ecosystems. Others pointed to oxygen. If the water turned still and warm, oxygen would vanish. Creatures would suffocate. Some blamed volcanoes under the sea. Others said bacteria had poisoned the water. No one agreed, but all saw the same thing, a sharp drop in life, and it was real. She laid out the samples from different countries side by side. The black lines all matched, their age, their chemistry, even their depth in the rock. They were the same event, and yet, no textbook called it a mass extinction, not yet. That's what made her pause. Because if this really was an extinction, it didn't belong on the list of 5, it belonged before them. It would become the first, the forgotten one, the silent reset before the big crashes we already knew. She imagined the world back then, warm seas, gentle waves, soft-bodied creatures drifting through the currents, tiny plants blooming in the shallows, the sky clear, the air full of light. Then something changed. The plants darkened, the waves stilled, the animals slowed, and one by one, they disappeared. No asteroid, no lava, just a shift, a quiet twist in the system that tipped everything over. And because so many of those early creatures didn't have hard parts, no bones, no shells, they left no fossils behind, that made it easy for the event to vanish, to be missed, but not anymore. She marked the layer with a red flag and took more samples. Her colleagues would test them for mercury, for sulfur, for carbon spikes. They would scan for signs of ancient storms, or sudden cooling, or underwater eruptions. Every detail mattered. Every clue could help explain what went wrong, and how fast it happened. Because the most important part wasn't the past. It was the pattern. Mass extinctions don't just erase life. They change the path of evolution. When the trilobites fell, other animals rose. When the reefs died, new builders came. Each extinction resets the world, clears the board, starts again, but the rules stay the same. First, a quiet shift. Then, a sharp drop. Then, slow recovery. Life finds a way, but it's never the same. That's what she feared most. Not just the death, but the change that follows. The black layer in the rock was a warning that even a quiet fall can shake the whole world. Later that day, she gave a talk to her students. She held up 2 rock samples, one from before the black line, one from after. They looked almost the same, but one was full of tiny shells, the other empty. She passed them around. Look closely, she said. You won't see a blast, or bones, or fire, but between these two rocks, a world ended. The students were quiet. One boy raised his hand. Could that happen again? She paused, then answered carefully. Yes. Not the same way, not with those creatures, but if the system shifts again, fast enough, deep enough, it could fall again. The wind outside shook the windows gently. The clouds moved slow across the sky. Everything felt normal. But the rocks never lied. A cold wind blew across the edge of the canyon, carrying tiny grains of dust that swirled in the early morning air. A team of scientists stood at the rim, looking down at the wide wall of rock stretched out before them. It looked like a rainbow made from time. Bands of red, grey, black, and yellow curved across the canyon face, each one a chapter in Earth's long story. But one layer stood out. It was narrow, only about 3 fingers thick, and it was almost black. That was the one they came for. That was the one that didn't fit. One of the scientists, a woman with a notebook tucked under her arm, took out a small brush and knelt beside a flat slab of stone that had broken off. She gently cleared away the dust. Her fingers moved slowly, carefully. She knew that this was not just any rock. This rock came from a moment when something changed. Long ago, something in the ocean, the air, or maybe even the land had broken balance, and many lives vanished. But the mystery was not just that life had died, it was how quiet it had happened. The rock layers below the black band were filled with fossils, small shells, bits of coral, worm trails. Above the band, the fossils were different. Sparse, fewer types, smaller shapes. There had been no loud event, no crater, no ash. Just a silence between layers. She looked up at her team. Same pattern again, she said. Another drop in diversity. Sharp, fast, then change. They nodded. They had seen this before, from Canada to China. From Morocco to Nevada, always the same story. Fossils rich, then thin, then new, but never quite like the ones before. In the lab weeks later, they tested samples from the dark layer. The results were strange. The carbon isotopes had shifted. That meant something in the carbon cycle had broken. Either something big had died off fast, or something new had taken over. There were also spikes of sulfur. That suggested low oxygen in the oceans. Maybe dead zones. Maybe toxic bacteria. And again, as in other spots, no clear smoking gun. Just the same sharp line of change. Sudden, global, silent. They plotted the numbers on a graph. It looked like a cliff. One moment, life was stable. Then, a steep drop. Then, a slow climb. It matched the shape of known extinctions: Permian, Devonian, Cretaceous. And now, this one. This strange one without a name. The problem wasn't just the missing bones. It was the missing proof. Mass extinctions, to be called that, needed data, layers, fossils, evidence from many places. This event had all those things, but not enough of each. It was like a puzzle with half the pieces missing. But the picture still looked clear. More papers were written. More labs ran tests. Still, many scientists hesitated. It's too early to call it a true extinction, they said. We need more sites. Others disagreed. If it walks like one, and acts like one, maybe it is one. One young researcher from Brazil pulled together samples from 9 countries. She stacked the fossil data and aligned the isotope curves. When she showed the chart at a small meeting in Germany, the room fell quiet. Her data showed a 60% drop in species across the same layer. That was huge. Maybe not as big as the Great Dying, but big enough to mark a major fall in life. And more than enough to ask, why isn't this already on the list? They started to give it a name. Quietly, at first. The Cambrian crash, or sometimes, the Black Line event. A few called it Extinction Zero since it might have come before all the others. One group even joked and called it the one we forgot. But jokes couldn't hide the weight of what it meant. If this was truly a missing mass extinction, then the story of life on Earth would need rewriting. The idea of 5 big events, 5 sharp breaks between old worlds and new ones, was part of every book, every chart. But if there were 6 or 7 or more, that would change everything. It would mean that Earth's history is even more unstable than we thought, that the rise of complex life was not smooth or steady, that there were hidden traps along the way, falls we didn't see coming. And if they happened before, quietly, they could happen again. That night, one of the team members stood alone in the canyon. The stars were bright above, and the rock walls glowed in the moonlight. He ran his hand along the stone, tracing the dark band with his fingers. He thought about the animals that had lived before that layer. Strange creatures, soft, squishy, with odd shapes. Gone now, forgotten, almost. No one knew their names. He wondered what it felt like to be part of a world that was fading. Did they notice the change? Did the water feel different? Did food grow scarce? Or did it happen so slowly that they never knew it was happening? Until one day it was too late. He picked up a small stone and tossed it into the canyon. It clacked softly as it bounced, then fell out of sight. The sound echoed once, then faded. Silence returned. Back in the lab, another email came in. A team in Japan had found a match. Same layer, same pattern. The count was rising. The line was growing longer. Soon it might be enough. The fossils still didn't scream. They still didn't shout, but they whispered louder now. And the world was beginning to listen. The room was small and quiet, filled with the low hum of machines. A single light flickered above the table, casting a yellow glow on the stacks of rocks, slides, and notebooks. On the screen nearby, a fossil image rotated slowly. It showed something tiny, no bigger than a fingernail, with soft edges and strange curling arms. It came from the black layer. The same black layer. Again. A woman leaned over the table. Her eyes were tired, but sharp. She had spent months looking at these samples. Layers of mud, silt, clay, all from the same time, all from different places. And in each one something was missing. Whole families of sea animals just gone. Not slowly, not scattered, but all at once, just above the dark band. Like the curtain had dropped between acts. Like the earth had paused and started again with a different cast. She opened a drawer and pulled out a thin grey tray. Inside were tiny labels with numbers and names. She had counted everything. The numbers told the same story, over and over. Before the black line, there were 24 types of trilobites. After, only 7. Before the line, reef creatures were everywhere. After, almost none. The more she looked, the more clear it became. This wasn't just a small event. It was a break, a sharp one, the kind that rewrites the map of life. Outside, the wind blew dry leaves across the gravel. Autumn had come early. The trees looked tired. Brown edges crept across the leaves. Even though rain had fallen all week, the skies stayed grey. Birds flew lower. The air smelled like wet soil and smoke. In the city, a boy walked through a museum with his father. They stopped at a wall of glass. Behind it, a full skeleton stretched out on a platform. "What's that one?" the boy asked. "That," said the father, "is a Dunkleosteus, a huge armored fish from long ago." The boy's eyes lit up. "Did it fight dinosaurs?" "No," said the father, smiling. "It died long before them." He pointed to a display showing a timeline of Earth. There were the big 5 mass extinctions. The boy traced his finger along them. "Where's the one that came before all of these?" he asked. The father paused. "Well, we're still learning about that one." Back in the lab, a young researcher stood in front of a chalkboard. She had drawn a thick white line across the middle and labeled it the Silent One. Below it were the creatures of the Cambrian. Above it, the strange survivors, some with armor, some with new shapes. "It's not just that things died," she said, pointing to the gap. "It's that the ones who came next were totally different, like the rules changed." Another scientist added, "Maybe it wasn't just extinction. Maybe it was transformation." But the mood wasn't hopeful, because they had started to see something familiar, something repeating, not just in rocks, but in now. In the ocean, warm zones were growing faster than ever. Oxygen was vanishing from deep water. Dead zones stretched for hundreds of kilometers. Plankton blooms came early, then crashed. Food chains shifted. Insects vanished from forests. Coral reefs bleached white, again and again. The numbers were sharp. The charts were steeper than ever before, and the pattern, it looked just like the ancient line. The earth wasn't quiet anymore. Fires burned longer. Storms spun slower, dumping more rain. Rivers ran dry, then flooded. Species disappeared, not one by one, but in clusters. Whole flocks, whole schools, whole forests. The scientists started to whisper, "It feels like the beginning of something," but others shook their heads. "It's already started." One of them ran a simulation. A huge computer screen showed a digital Earth. Colored rings pulsed across the oceans, red for heat, yellow for loss, purple for acid. The rings spread, layered, collided. At the end, a number flashed. 55% species loss in 300 years. The room went silent. They remembered the black line. Another team tested rocks from the present. They cut deep into Arctic cores. What they found made their hands shake. A new layer had started forming, just a few millimeters thick, but different from the ones above it. It was full of plastic, of ash, of changed carbon. It had the markers of a reset, a start of something new. One woman said it out loud. "We might be writing our own black layer now." That night, on the other side of the world, a man walked along a beach. The waves lapped at his feet. Pieces of coral washed up like broken glass. He bent down and picked one up. It crumbled in his hand. The reef was gone, no color, no fish. Just silence, the kind that matches the layers in the rocks. He thought of the word extinction. It always sounded like a bang, but now he knew it could be a whisper too. A slow hush, a soft fall, like a tide going out and never coming back. In the desert, wind carved new patterns into old dunes. In the mountains, glaciers melted faster, and in the rocks, the layers kept growing. The woman in the lab added a new label to her shelf. Possible sixths. She paused, then crossed it out, and wrote seventh. The story was changing again. The pattern had returned, and this time we were not just watching. We were part of the line. It began with a sound no one noticed, a low rumble under the feet of people walking down a quiet city street. It lasted just 2 seconds, then vanished. But across the ocean, that same day, a deep-sea sensor picked up the same vibration. 3 hours later, a volcano in the Southern Ocean released a wide plume of steam. It didn't explode, it didn't destroy, but it spoke. And those listening knew what it meant. Another sign, another piece. The pattern was no longer hiding. In a small lab on the edge of a rocky coast, an old scientist tapped his finger against a map. Colored dots covered it, red, yellow, purple. Each dot marked a place where something had gone wrong. Color gone here, oxygen lost there, a new fault line cracking deep under the sea. He had seen maps like this before, not exactly the same but close. Once when studying the Permian extinction, then again when modeling the Triassic crash. And now, here it was again. But this time, it wasn't old rock or fossil clues. It was real, it was now. He closed his eyes and remembered the line from an old report. Life ends not always with fire or ice, but sometimes with change too slow to feel, until it sips too late to stop. Outside the window, seagulls flew low over the water. Waves slapped the rocky shore. The ocean, which had always seemed endless, now seemed thinner, less alive, a shadow of itself. In the Arctic, ice cracked in straight lines, not natural curves. Scientists drilled and found dark meltwater beneath. That water held carbon, methane, and the remains of ancient pollen. Pollen from plants that had died out long ago, now returned to the surface. That meant old layers were melting into the new. Time was folding in on itself. One said softly, "The past is bleeding into the present." Another team, thousands of miles south, studied caves. In those caves were ancient stalactites and stalagmites, stone fingers that grew drop by drop, year by year. They sliced into one. The middle held a strange mark, a tiny gap in growth. It matched the black line found in the canyons and cliffs. That meant even deep underground, something had happened. Water had stopped. The cave had gone dry, then wet again. Even places untouched by light had felt the shift. Back in the lab, students gathered around a screen. On it was a giant fossil, a strange, soft-bodied creature with no eyes, no bones, just a shape. It had vanished long ago, right at the mystery layer. One student asked, "If we keep losing species now, will future scientists look back and wonder why we didn't stop it?" No one answered. Because stopping it wasn't easy. There was no single cause, no asteroid to block, no giant volcano to seal. The signs were everywhere, but they were small. A rise in sea temperature by 0.3 degrees Celsius, a fall in oxygen by 5%, an increase in plastic fibers found in fish stomachs by 200% in 10 years. Not one was huge, but together they pushed, like slow hands on a tipping scale. A girl in Ecuador planted a tree near a river where frogs had vanished. Her grandfather told her stories about how the forest used to sing at night with their calls. Now it was quiet. She didn't know about extinctions or black lines in rock, but she knew silence when she heard it. In a conference hall, lit with bright screens and loud voices, world leaders argued over charts and numbers. Some called it natural change. Others called it human damage. One stood and said, "We are not guessing anymore. We are measuring it, and what we see matches extinction." He showed a timeline. 5 great falls in life, and now a new one beginning. The audience shifted. A few clapped. Most stayed quiet. Because knowing something is coming doesn't always mean knowing what to do. One scientist wrote a note in her journal. "This feels like Act 15, not the beginning, not the end, but the part where the story turns, where the truth can no longer hide, where the silence becomes sound." At a beach in Australia, turtles crawled up at the wrong time of year, nesting early. Too early. The sand was too warm, and the eggs cooked before they could hatch. Children on a school trip watched and asked why. The guide explained gently that the truth was hard. The world is changing faster than the creatures can keep up. And in the canyons once again, the wind brushed past the cliffs. The black line was still there. Thin, sharp, quiet. But now, people knew to look. They measured. They studied. They named. In one last test, deep in a lab far below the ground, scientists crushed a rock from the ancient layer and compared its gases to modern air. The match was eerie. Methane spikes, carbon echoes, a warning hidden in stone now heard in our sky. Outside that lab, the rain fell harder than before. Rivers ran faster. The soil washed away in chunks, and above it all in the cloud-thick sky, birds flew less often. The pattern was no longer just a theory. It was a mirror, and we were standing inside it. Not all extinctions come with fire. Some come with forgetfulness, some with delay, but every one of them begins with a choice, made too late. And now, the world had to choose. The boy sat on the edge of a quiet field, watching the sun dip behind the hills. The grass was soft and tall, brushing against his knees. Birds once filled the sky here, but now he only saw 2, circling slowly like they were unsure where to land. The air felt warm, too warm for fall. The trees nearby hadn't turned yellow or red. They just stayed dull green, leaves curling at the tips. He picked one and held it up to the fading light. It was dry and brittle, snapping easily between his fingers. He frowned, then dropped the pieces to the ground. Across the world, in a busy lab filled with blinking lights and humming machines, a group of scientists leaned over a large table. On it were core samples, long tubes of rock taken from deep beneath the Earth's surface. Each tube was labeled, measured, scanned. The scientists didn't speak much. They were watching the data appear on the screens, line by line. One screen flashed red, a signal, a match, another black layer, another place, another sign. In just 3 months, 5 more sites had reported the same findings. Ocean sediment from the Atlantic, cliff faces in Argentina, dust trapped in Greenland ice. All from different times, all showing the same pattern. The pattern of a fall, not a single crash, but a series of stumbles. Like the planet had tripped over the same route again and again, each time harder, each time faster. One researcher whispered, "This isn't set just a 6th extinction, this might be something else." A second nodded. A rolling one, a slow storm that never ends. At the university, a teacher stood before her class, holding up a photo. It showed 2 layers of rock, one light, one dark. "This," she said, pointing to the dark one, "is where everything changed. Not just in the sea, but everywhere. It happened quietly, but it left a mark. We can still see today." A student raised her hand. "If it happened so long ago, and if life came back, why does it matter now?" The teacher paused, then said, "Because it SEP's happening again, and this time, we SEP are in it." In a forest clearing, bees swarmed low to the ground. They weren't visiting flowers, they were searching. The flowers had bloomed too early, and were now gone. The timing was off. 1 week too soon for the bees, 1 week too late for the birds who fed on the fruit that followed. The chain had snapped, a single link lost, and the rest began to fall apart. In a cave where stalactites grew drop by drop, scientists recorded a strange new trace: plastic fibers, trapped in ancient formations. Somehow, human-made bits had found their way into the deepest parts of the Earth. The cave had not seen sunlight in a million years, but now it held a mark of the surface. That meant time no longer protected the past. Back on the field, the boy saw something in the distance, a shape moving slow across the sky. It was a plane, dragging a banner. On it were words he couldn't read from where he sat, but he could see the colors, bright blue and green. A message, maybe, a warning, or a hope. The plane moved on, vanishing behind a grey cloud. In a small village by the sea, an old man walked the shore. He carried a notebook with weather dates written by hand, 40 years of tides and winds. He flipped to the newest page. It was empty. He hadn't known what to write. The ocean didn't behave the same anymore. High tide came early, storms circled twice before moving on. Fish were missing, birds nested farther inland. The sea had forgotten its rules. And yet, even with all this, life kept going. Children still played, music still drifted through open windows, markets opened each morning, but under it all, the pattern moved, like a shadow stretching slowly across a room, not fast enough to cause panic, just fast enough to make people wonder, had something changed? In another lab, one woman placed 2 fossils side by side, one from before the black layer, one from after. The older one was larger, stronger, full of complex shapes. The newer one was simpler, quieter. It's like life had to restart, she said, like it had to learn how to live all over again. And now, she feared, it might have to do that again. A news anchor read from a screen. Another coral reef gone, another animal added to the extinction list. Another warning from scientists. The words sounded flat, repeated, like old news, like something people had grown used to hearing. But this wasn't old. This was the middle of the story. Act 16. The part where the tension grows and the ground starts to crack. In an underground archive, a librarian placed a new book on a shelf. It was titled, The Hidden Sixth, Earth's Forgotten Fall. Inside were pages of charts, maps, and fossils. The final chapter was still blank. No one had written it yet. And in classrooms, students began asking new questions. What came before the Cambrian? Why do some layers of rock have no fossils? What if this is just one of many extinctions we haven't found yet? The teachers smiled, because questions meant thinking. Thinking meant change. In the field, the boy stood up. The light was almost gone. He turned to leave, but paused. In the quiet, he thought he heard something. A distant hum, low and soft, like the world breathing in. He didn't know why, but it made his chest feel tight, like something big was coming. Not fast, but close. He walked home slowly, not sure why he looked over his shoulder more than once. And above him, the stars came out. Silent watchers of a planet still writing its story. The ship rocked gently on the open sea. The waves rolled beneath it, smooth and glassy, as the sun rose like a golden coin on the horizon. A team of researchers stood near the rail, staring at a strange device being lowered into the water. It looked like a long silver snake, coiled with wires, blinking softly as it sank. They called it the Whisper, because it didn't make a sound. It was built to listen to the ocean, to the life inside it, and to the silence growing deeper every year. One of the researchers, a young man with salt in his hair, checked the tablet in his hands. The readings had started coming in. Salinity, pressure, oxygen levels. One number blinked red, then another. His face changed. The oxygen's lower than expected, he said. Voice tight, much lower. Others gathered around. They stared. There was a stretch of sea nearly 100 miles wide that held almost no oxygen at all. It was what they called a dead zone. No fish, no coral, no breath. Back in the lab on shore, data from other places matched the same story. In the Pacific, the Atlantic, the Indian Ocean, dead zones were spreading. Tiny at first, like ink dots, then larger, rounder, merging. One scientist marked them on a map, and the shapes began to resemble lungs slowly filling with dark air, breathing out less each year. They pulled old data for comparison. 20 years ago, the zones were patchy. Now they were spreading across entire coastlines. A red ring was forming near Alaska. A new one in the South China Sea. It's faster than we thought, someone whispered. No one argued. Across the globe, rivers swelled from sudden storms. They carried soil, plastic and fertilizer out to sea. What fed crops now fed algae, what fed algae now fed collapse. The water turned green, then brown, then grey. Fish floated to the surface, their eyes wide, mouths open. In just 6 days, one bay lost 90% of its life. A girl who lived nearby drew a picture of the water. She colored it black, with white X over the fish. Her teacher asked what it meant. She said, "They went away. They couldn't breathe." Meanwhile, in an inland valley far from the sea, crops failed. The rain had shifted east that year. The soil dried into long cracks. A farmer knelt down, scooped a handful, and watched it crumble into dust. The pattern of wet and dry no longer followed seasons. It followed something else, something harder to track. It seemed random but wasn't. It followed heat. The heat was rising. In forests near the equator, trees began to die. Not from fire, not from axes, but from exhaustion. Leaves turned yellow in weeks. Animals moved deeper into the woods, chasing cooler shadows that shrank each day, and some didn't run fast enough. One by one, small creatures disappeared. First the frogs, then the birds, then the insects that made the forest sing. In cities, people noticed, but not always in ways they could explain. Allergies got worse. Gardens didn't bloom right. Fruits grew too early, or not at all. One woman kept a journal of plants she saw on her walk. The entries grew shorter. Lilacs gone by May, she wrote. Bees fewer than last spring. Then, nothing blooming today. The signs were piling up like a slow tide. Most didn't feel like disasters. They were quiet shifts, but to those watching closely, they were loud. The sixth extinction, the one unfolding now, wasn't a single crash. It was a long slide, covered in silence. But then, something happened that made people stop. A coral reef in the Red Sea, one of the last still alive, turned white overnight. Not just part of it, all of it. Scientists dove down early the next morning. The water was too warm, the oxygen too low. And something else, an odd smell, like metal. They took samples. When they reached the surface, their faces were pale. One scientist whispered, "It sips like a ghost of what used to be here." News spread fast. Photos went viral. White reef, empty water, no color, no fish, no motion, just bones of stone. This time people paid attention. For a moment, the world leaned in. The reef had always been the symbol of life's beauty. Its loss became a question mark in the sky. How close were we to becoming that reef? Back at sea, the whisper brought in more data. It found a heat spike in the deep sea, nearly 0.9 degrees Celsius warmer than the year before. That may not sound like much, but to creatures that had lived at a steady temperature for millions of years, it was a wave of fire. Tiny shrimp at the bottom of the sea disappeared. With them went the fish that ate them. With those fish went the larger ones. The chain snapped again. The team looked at the data, blinking on the screens. One map showed a swirl of warm water rising from the deep, spreading like ink in a clear pool. The boy in the classroom looked at the same image. His teacher said, "That sips the ocean now." The boy raised his hand. "What does that mean for us?" The teacher didn't speak right away, then said, softly, "It means we need to listen before the water goes quiet." In a canyon far away, the black line in the rock still held its silence, but people no longer ignored it. It had become more than a fossil story. It was a mirror. And now, the mirror looked back. One final reading came in. A scan from the Arctic, where the ice had cracked. Trapped inside that ice, scientists found gases never meant to escape: methane, carbon, sulfur, ancient signs of old falls, now being released again. The whisper had heard enough, and so had we. The wind moved through the valley in soft, uneven breaths. It carried the smell of ash and salt, even though no fire burned nearby and the sea was over 50 miles away. Something felt off in the air, not wrong like danger, but strange, like forgetting a word you should know. A girl sat by a cracked riverbed, sketching the ground. Her pencil moved slowly across the paper, tracing the jagged lines in the dirt. It hadn't rained in months. The river, once full of frogs and reeds, was now just a scar of dry stone and curled leaves. Her grandfather watched from a nearby bench. His hands rested on a cane that had belonged to his grandfather. He had lived through storms, heat waves, and even the Great Flood of '82, but he had never seen the land stay dry for so long. "It's changing," he whispered. "The Earth's rhythm. It's not beating the same." Across the world, ice cracked again. This time in Greenland, a shelf the size of a small city broke off and drifted silently into the sea. Satellites watched from above. They marked the shape, measured the temperature, and labeled the moment. Another loss. One more step in a march no one could stop. In a lab beneath a mountain, a woman adjusted a scanner to read carbon trapped in old shells. The shells came from deep ocean mud, taken by a drill that had reached nearly 2 kilometers down. She turned the knob slowly. On her screen, tiny spikes showed up. Some were old, some were new, but the shape was the same. A quick rise, then a drop, then silence. It was the same pattern from past extinctions, and now it was back, wearing a new face. The world hadn't ended. Not yet. People still woke up, made breakfast, played music, sent messages, but small things had shifted. Fireflies didn't blink as often in the fields. The sky stayed orange longer after sunset. Whales swam closer to shore, confused by sound waves that echoed oddly through warming water. Dogs barked at night for no clear reason. Things that once made sense didn't anymore, and that made people feel uneasy. In the city, a large screen displayed air quality. Yellow for mild, orange for caution, red for danger. Lately, the red lights stayed on longer. Children wore masks not just for sickness but for air thick with dust and smoke. One boy looked up at the sky and asked his mom, "Did the clouds used to be whiter?" She smiled but didn't answer, because she remembered they were. Meanwhile, another group of scientists stood over a fossil dig site. They had found a layer where almost everything stopped. Then, a few inches above, a new kind of life began. Smaller, faster, quieter creatures. Survivors, not better, just different. One of the scientists stared at the gap between the layers and said, "This is where the old world ends and the next one tries to begin." On the other side of the world, near a desert blooming strangely out of season, a man placed his hand on a tall cactus. Its skin felt hot to the touch. He squinted at the sun. It was only 9 a.m., but already 36 degrees Celsius. Birds called from deep within the shade, unwilling to fly. Flowers wilted before they fully opened. He poured water into the roots and whispered, "Hold on." Data from Antarctica came in. Soil there, frozen for 2 million years, had thawed and released spores of ancient fungi. Lab tests showed they were still alive, not dangerous, just waiting all this time, now waking into a world they didn't belong to. One scientist joked, "Even the past wants to come back now," but no one laughed. The old black line in the canyon rocks was no longer just a mystery. It was a mirror. Each act we played now had a matching echo in the past. The oceans losing oxygen. It happened before. The forests drying out. Same. The sudden silence in certain skies and seas. All of it matched the signs that came before the other mass extinctions. The difference now was time. Before, the falls took thousands of years. This time, it was happening in less than 200. A young girl stood beside her teacher, staring at a display in a natural history museum. The exhibit was about mass extinctions. She pointed to the end Permian and asked, "Did anyone try to stop it?" The teacher shook his head slowly. There wasn't anyone around who could. The girl paused. "But this time, we are here, right?" Her voice was soft. "So maybe we can do something?" In a hidden room at a university, an emergency meeting took place. Scientists, leaders, and storytellers came together. No cameras, no press, just voices and numbers. They looked at the charts. Sea level rise, carbon spikes, extinction curves. The curves were no longer curves. They were cliffs. One man stood and said, "If we don't change, the black line we're watching for will become the one we leave behind." The room went quiet. Not scared, just still. Because they all knew it was true. And still, there was no asteroid. No single, sudden blow. Just heat. Just hunger. Just silence. Just time slipping too fast. But not everything was lost. Yet, in a jungle in Borneo, a camera caught the return of a rare bird thought to be extinct. It sang once, then flew off into the green. A small spark. But a spark, still. A girl in Iceland sent a seed to a vault in Norway. She wrote a note, "For the world after this one, just in case." A diver off the coast of Japan placed a small metal ring around a new coral bud. It was growing. Slowly, gently, but it was real. And in a cave where ancient winds once carved stories into stone, a new carving appeared, not from nature, but from a human hand. A simple mark, a swirl, a spiral. It meant, we saw, we knew, we tried. And high above all of it, satellites watched. Quiet, cold, steady. Their sensors blinked as the Earth turned below, carrying its stories, its warning signs, and its people, still writing the next part of the story. The mountain wind carried a strange mix of smells: pine needles, wet stone, and something faintly sweet, like flowers blooming too early. A boy stood at the edge of a ridge, holding a worn pair of binoculars. He had been coming here every week for months. Below him stretched a long valley once filled with birds. He used to count them: hawks, finches, even the bright green parrots that had escaped from someone's old house and made this place their home. But now, most days, he saw nothing. Just sky, just wind, just silence. Still, he came. He wasn't waiting for the past to come back. He was waiting to see if the future would look different. Far across the ocean, a quiet lab buzzed with sound. Machines clicked and blinked. On the main screen was a new map of the Earth. But this wasn't a map of borders or cities. This was a map of life. Every dot was a species. Green for safe, yellow for threatened, red for vanished. As they watched, a small dot in the Amazon shifted from yellow to red, a bird with feathers like fire. Gone. A scientist closed her eyes. Another story ended before most people had even heard it. But something else blinked on the map too. A blue light. Not life lost, but life found. A small plant growing near an old mining site in Australia. It had been thought extinct for 80 years. Now, somehow, it had returned. Tiny and tough, pushing up between rocks. One researcher whispered. It remembered how. All around the world, stories like that were beginning to appear. They were small, quiet, but real. A group of children in Kenya started a butterfly garden behind their school. At first, nothing came. Then, after weeks, one landed on a leaf. Then another. By the end of the month, dozens of wings fluttered through the garden each morning. The children gave them names. Laughter mixed with the wind. Hope found a way to bloom. In northern Canada, snow fell softer than usual. A herd of caribou crossed the white plain, hooves crunching. A team of trackers followed from a distance. They weren't hunting, they were watching, measuring, hoping. The herd had shrunk in the last 10 years, but this season something changed. New calves had been born, more than expected. They stumbled through the snow, learning the world one shaky step at a time. Sometimes, survival doesn't stood raw. Back in the city, a group of students painted murals on the sides of buildings. They showed forests, whales, bees, and flowers. One showed the earth with bandages. Another showed the earth with hands holding it up. People walking by stopped to take pictures. Some smiled. Some paused longer, reading the words painted below. We are still writing the ending. On an island off the coast of Japan, a coral restoration project began to show progress. Not fast, not everywhere, but enough. Divers found new polyps, tiny builders of reef walls, stretching out soft arms to catch plankton. The water was still warm, still risky, but life hadn't quit. It was trying. A team in Brazil mapped out a hidden patch of rainforest that hadn't been cut, burned, or cleared. Inside it were dozens of species never recorded before. One of them was a tree that released its seeds only once every 100 years. This was its year. They fell like soft rain, bouncing gently on the moss below. The forest knew when to wait, and when to begin again. A boy in a wheelchair planted seeds along the side of a busy road in Spain. People watched him work, unsure what he was doing. But weeks later, bright yellow flowers lined the path. Bees came, butterflies followed. Some drivers slowed down just to look. The boy smiled each time he passed them. One small row of color in a world that needed it. The black line in the rock was still there, still silent. But now, something had changed. People weren't just looking at it with fear. They were looking with understanding. This wasn't just a warning anymore. It was a question. What do we want the next line to look like? One morning, scientists around the globe opened their computers and found a message shared between labs. It showed 3 graphs: carbon levels, extinction rate, and ocean heat. For the first time in decades, all 3 had stopped rising. They hadn't dropped yet, but they had paused, flattened. It was like the Earth had taken a breath and was waiting to see what we'd do next. The moment was fragile, like a glass bridge stretched between 2 cliffs. A girl in a small village read the news and told her grandmother, "Maybe we sep turning the page." Her grandmother said, "Just don't drop the pen." The boy on the ridge raised his binoculars again. Still no birds, but the wind felt different today, cooler, with a hint of rain. He sat and waited, eyes scanning the sky, and then, just above the tree line, he saw it. One shape, wings outstretched, gliding slow and steady, a hawk. It circled once, then vanished behind a cloud. The boy smiled. Not because everything was fixed, but because something had returned, and sometimes something is enough to begin again. The sky over the valley was blue again, not just light blue like a faded shirt, but deep and clear, the kind of blue that made your eyes want to stay there. A soft breeze moved through the tall grass, brushing it in waves that looked like the sea. Bees buzzed from one yellow flower to the next, and far above, a hawk circled lazily, wings stretched wide. The boy from the ridge sat cross-legged on the same rock he always chose. His binoculars rested on his lap, but he didn't need them now. The birds had come back. Not all of them, but enough. He smiled and looked out over the land. It was still healing. There were still dry patches, still broken trees, still pieces missing, but there was also green. There was sound, there was motion. The forest was not finished, but it had not given up. In the distance, he heard laughter. Children ran through the grass, chasing butterflies and each other. Their shoes kicked up bits of dust and seeds. The air smelled like damp earth and sweet pollen. Somewhere behind him, a radio played soft music from a porch, and nearby, a small wooden sign stuck in the ground read, "This land remembers." Across the world, in places far from this valley, other signs appeared. Some carved into stone, some painted on school walls, some just whispered from one voice to another. They all meant the same thing: we saw what could have happened, and we chose something else. The map in the city lab looked different now. Red dots had stopped spreading, some even faded to yellow, and in one corner, new green dots blinked, bright and hopeful. They weren't huge wins, but they were real. The scientist looking at the map stood up and said, "We're no longer tracing the fall, we're tracing the climb." In the oceans, coral slowly returned in tiny patches, not the giant reefs of the past, but starter homes for fish. Bright bursts of color growing from grey stone. Schools of small silver fish darted between them. Dolphins followed, and soon sea turtles glided past, their flippers wide and slow, as if painting the water with every stroke. On land, rain patterns began to shift back. Forests that had gone silent found their voices again. Birds sang, frogs called. Even the wind through the leaves seemed to whisper with joy. In the desert, cactus blooms opened earlier and wider than ever before, and high in the mountains, snow stayed longer into spring, soaking into thirsty ground below. People were different too. Not all at once, but something had changed. They had seen the black line in the rocks, they had seen the dead zones, the melted ice, the empty skies, and they had also seen what happened when they chose to care. So they planted trees, built cleaner machines, saved water, protected animals, and most of all listened. In classrooms, children now learned not just the names of dinosaurs and volcanoes. They learned the names of rivers near their homes. They learned how to measure air and test soil. They studied the 5 great extinctions, not as old sad stories but as warnings we had almost repeated. And when they asked about the 6th, teachers now said, "We walked the edge but turned back." One school held a ceremony. The students made a circle of stones in the playground and buried time capsules under each one. Inside, they placed pictures of animals, leaves, and poems they had written. One poem read, "We heard the silence and chose to sing louder." The earth still had its scars. The sky still had haze on some days. The oceans still carried too much heat. But the line had curved. The free fall had slowed, and that mattered. The black layer in the canyon remained as it always had. Sharp, thin, silent. But now, next to it, a new line was forming. Not black, not dark, but pale, soft, and filled with life signs, pollen grains, shells, spores, seeds. It was not a line of death. It was a line of return. And geologists, centuries from now, would one day slice into the rock and find it. They might say, "This is where they stopped the 6th." And they would be right. In the space above Earth, satellites still circled. They still watched, still listened. But now they sent back pictures of green patches growing where deserts used to be, of animals walking old paths again, of glaciers moving just a little slower. One final image came from a satellite, as it passed over the ridge where the boy still sat. It zoomed in just enough to catch him waving at the sky. The signal was faint, but it came through clearly. The message that followed was short. Still here. The last bird of the day flew across the valley, not fast, not scared, just flying, like it had always done. And down below, the boy stood and turned homeward, one hand brushing the tall grass, the other holding a notebook filled with drawings, names, and dreams. The sun dipped low, casting golden light across the land. And the world, which had once been so close to silence, kept singing.